Okay, now to wrap up our discussion concerning um, unsaturated compounds, we're going to look at benzene. Okay, benzene is the prototypical aromatic compound. Okay, so like we said before, we are going to basically use this as our definition for an aromatic compound for this course. Just know that the definition does become more complex when we take organic chemistry. Okay, so here you can see that we have alternating single and double bonds between carbon atoms. Okay, now this is kind of a pain to draw like this every time, so it's much more customary to draw this out like this, just kind of using these line diagrams or line structures. Okay, so again, the name of this compound is benzene. And what makes benzene so interesting is what it doesn't do. It doesn't react very well. And even though it looks like it is composed of three double bonds, the molecule does not easily undergo the reactions that double bonds usually undergo. It's unusual. In fact, this lack of reactivity was something that really made it difficult for chemists to accept what the structure of benzene really was. But we do know now that benzene is in fact going to be this six-membered ring. But it's not quite going to be composed of alternating double bonds and single bonds. You see, when you look at the benzene ring, okay, we see a bond here, here, and here that appears to be a double bond. And like every other bond, this bond is going to be made up of electrons. And we saw back in the earlier chapters that two electrons make up a bond. Well, we as human beings like to have things organized nice and tidy, so that's why we draw these bonds being specifically where they are. But there really isn't any reason why we couldn't have drawn it like this. Okay, and you might be thinking, well, it's the same thing as what we had before. What's the difference between the two? We didn't just simply rotate this. In fact, if we were to kind of color code these carbons here, okay, we would notice that there's a key difference in where the double bonds and single bonds are. Okay, you can see in the compound on the left-hand side that the double bond is taking place between the red and the green carbon. Whereas in the compound on the right-hand side, there's a single bond between them. Okay, and that's because the electrons really aren't tied down to that particular region of space. In fact, those 6 electrons that make up those double bonds are really being shared all the way around the ring. In fact, this is a very reasonable structure for benzene. It makes it a little bit trickier for us when we're trying to count electrons, but this is a much better representation for how this behaves. Okay, and we can say that these are all resonance structures. Okay, and because these electrons are kind of being spread out over the entire ring, they're not quite as available for reacting, which explains why benzene doesn't react quite as much as other alkenes would. So that's the big explanation for why benzene behaves the way that it does. Now, in terms of naming aromatic compounds, this can be a little bit complicated because there's a lot of common names that have been so well established in the scientific literature that a lot of the common names have become the systematic names. So I'm not asking you guys to memorize or to remember any of these names here, but I just want to show you some of the names. Okay, so suppose that you have a benzene ring. Okay, we put aldehyde on it. Okay, we call this benzaldehyde. And benzaldehyde is a very sweet smelling compound. Smells a lot like almonds or maraschino cherries. Now, related to that, we could put a double bond in between the benzene ring and the aldehyde, and we wind up with cinnamaldehyde. And I think you can deduce from the name what that is the smell of. Okay, and there's a lot of other compounds out there, like naphthalene, where we have two benzene rings kind of fused together. And naphthalene is the stuff that's in mothballs. So if you've ever smelled that, that's what you're smelling. Another example would be let's see here. Another one of these aldehydes. Okay, and this has another very descriptive name, vanillin. Again, this is the compound that gives vanilla its flavor, its smell. Okay, and you can get an idea now for why it is that aromatic compounds have earned this name of being aromatic, because these are all things that have very strong aromas to them, and this is just a handful of them. I mean, things like spearmint are also compounds that are aromatic, but there are many compounds that contain the same sort of framework that do not have any smell associated with them whatsoever. For example, this compound right here, which is potassium benzoate, is a popular preservative used in beverages, a lot of carbonated beverages. And this has no smell whatsoever. So with that being said, you can't really say that all aromatic compounds necessarily have an aroma. It's just that they kind of adopted that name because so many of them did have a very strong smell, and that's why they were so easily discovered.